this video, we'll continue solving math applications SL, paper 1, May 21. Let's get started. Question number 11. If a shark is spotted near to Brighton Beach, a lifeguard will activate a siren to warn swimmers. The sound intensity I of the siren varies inversely with the square of the distance d from the siren where d is more than 0. So here we are talking about inverse proportion, varies inversely. It is known that at a distance of 1.5 meters from the siren, the sound intensity is 4 watts per square meters. So, first, it is given that the I, the intensity, the sound intensity of the siren varies inversely 1 over the square of the distance d, so d squared. This can be written also as I equals k over d squared. And then it's given information that when d, the distance is 1.5 meters, sound intensity is 4 watts per minute. I is 4 watt meter squared. Show that I equals 9 over d squared. How we would show that? So here, all what we need is to substitute the value of d, the value of I here, given values, we need to substitute it into this equation, the equation of the inverse variation. So when we substitute, we will get 4 equals k over 1.5 squared. Now we can do the cross multiply. 4 times 1.5 squared, we will get k equals 9. Okay, after finding k equals 9, we will substitute it back here. Then we will get I equals 9 over d squared. So this is part A. Part B, sketch the curve of I on the axis below, showing clearly the point 1.54. So here is the axis given. D, this is the x-axis from 0 till 6, and I from -5 till 20. All what we need to do is to enter this equation into our graphing calculator, into graphing, so it will be y equals 9 over x squared. Then we will draw, and we will copy whatever we will see in our calculator screen, we will copy it into our paper. And if you couldn't receive appropriate graph in the calculator, all what we need is to adjust the window of the calculator. So x needed to be from 0 till 6. This is what is the given boundaries here. And the y from -5 till 20. So you need to adjust the window of your calculator screen if you didn't receive appropriate graph. Once you will receive the graph, you will copy it here. Oops. And we can see that we should start from here or above and going down towards 6. And of course our graph is continue after 6 here, and it will be above the 20 in the y-axis. And it's concave up. And where is the point here? We can see that if this is 6, so in the middle here, this is 3. So 1.5 is approximately here. So this is our 1.5, 4. Here is the 1.5, and here is the 4. So this is the graph, and we know that this graph will never touch the x-axis. It's just coming close to the x-axis, and also it will never touch the y-axis, just coming close to the y-axis. And this is the point 1.54. So this is part B. Then C. Whilst swimming, Scarlett can hear the siren only if the sound intensity at her location is greater than 1.5 times 10 power negative 6. So the given information saying that Scarlett can hear the siren only if the sound intensity, I, at her location is greater than 1.5 times 10 power negative 6. So we would write I more than equal 1.5 times 10 power negative 6. This is the given information. The question C. Find the values of D where Scarlett cannot hear the siren. Find the values of D where Scarlett cannot hear the siren. This is important because what I just wrote here, this is the intensity when she can hear the siren. So she can hear the siren only if I is more than 1.5 times 10 power negative 6. But we need to find the values of D where Scarlett cannot hear the siren. So I, we know it's 9 over D squared. If she cannot hear the siren, this means it will be less than or equal 1.5 times 10 negative 6. Then we will cross multiply to get D. We are finding D, so D squared more than or equal 9 over 1.5 times 10 power negative 6. Then take the square root. D more than or equal 249.48 and so on. And we may write D more than or equal 2,450 meters. So she cannot hear the siren if the distance is more than or equal to 2,450 meters. This is question number 11. Glad to see you, and I'm waiting to receive all your questions into my Facebook page, Instagram account, Twitter account, and also into this video's comments. If you have any question, I will be glad to answer. And goodbye, see you next video. Bye.